A powerful burst of gamma radiation lasted a mere half second, but it released an enormous amount of energy. It was more than our sun would produce in 10 billion years. This brief flash lit up the whole sky. Afterward, a much softer and more long-lasting glow replaced it. Astronomers examined the phenomenon with X-ray, radio, optical, and infrared waves. It turned out that people had finally seen a newborn magnetar for the first time ever. It was likely formed after two neutron stars had merged. It resulted in a kilonova, one of the brightest and largest stellar blasts. Its light finally reached our planet on May 22, 2020. Imagine a massive star, at least 5 times the mass of our sun, reaching the end of its life. It might be because it's run out of its nuclear fuel. If it happens, the star starts to cool off. The pressure inside drops, and the gravity starts to squeeze inward. And then, more than 1 million times the mass of our planet collapses within 15 seconds. It happens so fast that an enormous shock wave causes the outer part of the star to blow up. It produces a blinding burst of light. This powerful blast is called a supernova. What's left behind is an incredibly dense core with a huge cloud of hot gas, called a nebula, expanding around it. If the star has been massive enough, more than 10 times the size of the sun, it's likely to turn into a black hole. If not, it turns into a neutron star. It's basically a giant nucleus, the central part of an atom. These stars are mostly made up of neutrons and are rarely larger than 20 miles across. For comparison, our sun is almost 865,000 miles across, which is 109 Earths put side by side. But don't let this relatively tiny size fool you. Any neutron star is at least 1.5 times heavier than our sun and has an intense magnetic field. If you scooped just a teaspoon of this star's insides, this matter would weigh more than 1 billion tons. It's so dense that it makes neutron stars some of the most extreme objects people know about. The next stop is the black hole itself. When two neutron stars merge, they most often create a new, much heavier one. Within milliseconds, or even less, this star collapses into a black hole. But the astronomers who examined the flash of light recorded in March think there might be another outcome. They're almost sure they saw something never observed before: the birth of a magnetar. That's a rare form of a neutron star with an ultra-strong magnetic field. It's 1,000 trillion times stronger than our planet's. This field is also so powerful, it heats the star's surface up to 18 million degrees Fahrenheit. To put it simply, magnetars are the most powerful magnets in the universe. Their magnetic fields can seriously mess with the neighborhood. Atoms, unlucky enough to get close to such a star, get stretched into pencil-thin lines. If you somehow found yourself several hundred miles away from a magnetar, it would end badly for you. The magnetic field would first disrupt your bioelectricity. It means that your nerve impulses wouldn't work anymore. Even your molecules would change under the influence of the star's field. In the end, you'd pretty much vanish. If a magnetar flew within 100,000 miles from our planet, it would wipe out all the data on every single credit card in the world.
The protective shield of our planet decays and eventually fails. So do our satellites. First, communication satellites in the highest orbits go down. Next, astronauts in low Earth orbit can no longer contact their mission control center. And finally, hazardous, relentless cosmic rays start bombarding everything on Earth, causing havoc and devastation. Are these the terrifying consequences of the planet's magnetic field reversal we're going to face? Right now, as you're watching this video, Earth's north magnetic pole is extremely out of whack. It's so serious that scientists will have to update the global magnetic field model released a mere 4 years ago. Does it all mean that the magnetic pole of our planet will flip soon? Well, be patient, we'll figure it out a bit later. You see, the magnetic pole is moving quite erratically from the Canadian Arctic towards Siberia, and these movements are very unpredictable. But it's normal for the pole to be moving. There are long-term records from London and Paris that prove that the North Magnetic Pole moves randomly around the rotational North Pole over periods of several hundred years. But the most astonishing thing about its movement is that it's speeding up. Around the mid-1990s, the magnetic pole unexpectedly accelerated from a bit over 9 miles to 34 miles a year. And recently, the pole crossed the international dateline, moving toward the eastern hemisphere. The European Space Agency launched extremely accurate magnetic field satellites in 2013. Thanks to them, researchers have superb data they can use not only to make magnetic field maps, but also to update them every 6 to 12 months. That's how they were able to notice that the core field was weakening too. It might be a sign that the planet's magnetic field is about to flip. To understand this process better, we need to figure out how the core field works. Let's say we've got a bar magnet that runs through the center of our planet and has a north and a south pole. This magnet is incredibly strong, representing about 75% of the intensity of our planet's magnetic field at the surface. Our bar magnet is not only moving, but is also getting weaker, by about 7% every century. Admittedly, this bar isn't the perfect representation of the core field. It's more like electric currents generating Earth's magnetic field. Still, this model makes it easier to see what's happening to our planet now. The magnetic field of our planet plays an important role in protecting us from dangerous radiation and geomagnetic activity, which is the product of the interaction between the solar wind and Earth's magnetosphere. Earth's magnetic field also moves. Scientists have been studying and tracking the movement of the magnetic poles for hundreds of years. The historical motions of these poles indicates changes in the global geometry of the magnetic field of our planet, and they may point to the beginning of the field reversal too. That's what the flip between the north and south magnetic poles is sometimes called. You see, if the north magnetic pole moves a bit, it isn't a big deal. But a complete reversal might have a serious impact on the climate of our planet, as well as modern technology. Luckily, such flips don't happen overnight. The entire process stretches over thousands of years. Plus, even though the magnetic pole weakens during a pole reversal, it doesn't disappear completely. So those scary events from the beginning of the video aren't likely to happen to us. The magnetosphere will continue protecting the planet from cosmic rays and charged solar particles, even though there might be some amount of particulate radiation that will make it to Earth's surface. Magnetic fields are generated by moving electric charges. If some material allows these charges to easily move in it, it's called a conductor. Metal is a great conductor, and we often use it to transfer electric currents from one place to another. In this case, the electric current is negative charges called electrons moving through the metal. The current is what generates a magnetic field. Earth has a liquid iron core. In other words, there are layers and layers of conducting material inside our planet. Currents of charges are constantly moving through the core, and the liquid metal is also moving and circulating there, generating the magnetic field. This magnetic field, in turn, produces something resembling a bubble around the planet. It's called the magnetosphere, and it's located above the uppermost part of the atmosphere. This layer shields and deflects high-energy cosmic radiation, which otherwise would be extremely dangerous to people and other forms of life on Earth. The magnetosphere also interacts with the ionosphere, the layer of our planet's atmosphere containing loads of ions and free electrons and capable of reflecting radio waves. The interaction between these two layers and the magnetized solar winds is what scientists call space weather. The solar wind is normally mild, and there's no space weather whatsoever. But sometimes, the sun starts shedding gargantuan magnetized clouds of gas that can accelerate to incredible speeds. They're called coronal mass ejections, or CMEs. They're ejected from the sun over the course of several hours. CMEs usually look like giant twisted ropes and can occur spontaneously. Their frequency varies according to the 11-year-long solar cycle. For example, at a solar minimum, you can observe one ejection per day, and when the sun is in its most active phase, there might be 3 CMAs per day. Coronal mass ejections disrupt the calm flow of the solar wind and cause serious disturbances that can damage stuff both in space near Earth, like satellites, and on the planet's surface. If coronal mass ejections make it to Earth, their interaction with the magnetosphere generates geomagnetic storms. Those can trigger auroras, happening when a stream of energized particles hits the atmosphere and lights up. And then there are also solar flares. They develop more rapidly and with much more energy than coronal mass ejections. Solar flares often occur soon after coronal mass ejections. The most powerful volcanic eruptions pale in comparison to solar flares that release 10 million times more energy. Within a few minutes, one solar flare can give out billions of tons of charged particles. Solar flares are also insanely hot, with temperatures reaching several million degrees Fahrenheit. Astronomers believe that such bursts of solar radiation happen when the sun's magnetic field gets twisted in some regions. At one moment, all the pent-up energy is released. The star sends out light and particles, mostly electrons and protons. Most solar flares last for minutes, but some continue for hours. A powerful solar storm can potentially cause a devastating global blackout on Earth. If not for the Earth's magnetosphere, the effects of the sun's activity would be much more devastating. Luckily, the magnetosphere deflects most of the solar material hurtling towards our planet from our star at a speed of over 1 million miles per hour. But even so, during space weather events, there's a lot of hazardous radiation near Earth. It can potentially harm astronauts and spacecraft. Plus, space weather can damage large conducting systems, for example, pipelines and power grids, by overloading currents running inside them. Scientists regularly map and track the overall orientation and shape of our planet's magnetic field. To do it, they use local measurements of the field's orientation and magnitude. That's why they've been able to conclude that the location of the North Magnetic Pole has moved by almost 600 miles since the first measurements were taken in 1831. The magnetic field of our planet reverses on a timescale varying between 100,000 to 1 million years. One can tell how often it happens by looking at volcanic rocks at the bottom of the ocean. They capture the orientation and strength of Earth's magnetic field at the time of their creation. So, dating those rocks gives us a good picture of how our planet's magnetic field has evolved over time. From a geological point of view, field reversals happen quite fast, but they are extremely slow from a human perspective. A complete reversal normally takes a couple of thousand years, but during this time, the orientation of the magnetosphere may shift, exposing more of Earth to cosmic radiation. Such events tend to change the concentration of ozone in the atmosphere. In any case, scientists can't say for sure when the next field reversal will happen, but they keep mapping and tracking the movement of our planet's magnetic north. By the way, the Earth isn't the only planet with a magnetic field. Gas giants, like Jupiter, also have a conducting metallic hydrogen layer that generates their magnetic fields. Jupiter's internal magnetic field prevents the solar wind from interacting directly with the planet's atmosphere.
Buckle up, fellow space enthusiasts, because we're about to uncover the celestial secrets that have been unveiled this year. From giant stars to organic molecules, this year is going great for astronomers. So let's catch up on all the excitement you might have missed in 2023. First of all, we've discovered some real astral monsters. Imagine looking up at the night sky and seeing stars that are not just big, but absolutely enormous. Scientists have been using a special telescope called the James Webb Space Telescope to explore the early days of the universe. And during their adventure, scientists stumbled upon ancient stars that are 10,000 times bigger than our sun. Yes, you heard it right, 10,000 times. These giants of the stellar world were some of the very first stars ever to form in the universe, billions of years ago. Imagine a globular cluster as a massive cosmic crew, where each group consists of a whopping 100,000 to 1 million members. These clusters are like giant family gatherings, with all the stars being born around the same time. But what makes these newly discovered monsters so special? Well, their cores, or their central parts, are way hotter than what we see in stars today. Scientists think that this intense heat might be due to a lot of hydrogen burning at really high temperatures. It's like they're having a galactic barbecue party. Something fascinating happens in these globular clusters. The smaller stars crash into the supermassive ones and gain extra energy, like a power-up. But here's the twist. Most of these clusters are now getting old, and the supermassive stars disappeared a long time ago. We can only see hints of their existence in the clusters we observe today. Scientists study them by just the mysterious traces of their grand presence. The discovery of these monster stars is incredibly important for our understanding of the universe. If scientists can gather more evidence to confirm their existence, it would be a major breakthrough. It would help us learn more about globular clusters and how supermassive stars form in general. But that was only the first fascinating discovery of 2023. Although the next one is kinda sad. You know those beautiful rings that make Saturn look so fancy? Well, guess what? They might disappear in the not-so-distant future, astronomically speaking. NASA's Cassini mission, which explored Saturn from 2004 to 2017, gathered some fascinating data about the rings. During Cassini's grand finale, when it did some cool maneuvers between Saturn, scientists noticed something surprising. The rings were losing a lot of mass every second. Tons of it. That means this magnificent halo will only stick around for a few 100 million more years, at most. That may seem like a long time for humans, but in the grand scheme of the universe, it's just a blink of an eye. The important thing is that we've learned that huge rings like Saturn's don't last forever. They eventually fade away. Oh, well, at least you and I personally won't catch this moment. Scientists have a fun theory about what will happen when Saturn's rings disappear. They think that the other ice and gas giants in our solar system, like Uranus and Jupiter, might have once had massive rings too. But over time, those rings wore down and became more like the thin, wispy bands of asteroids like what Uranus has now. Saturn's rings are mostly made of ice, but they also have a sprinkling of rocky dust. This dust comes from asteroids and teeny tiny meteoroids crashing into the celestial objects and breaking apart. It's like a snowstorm of icy particles and space debris. The research also revealed that Saturn's rings appeared long after the planet itself formed. They were still forming when dinosaurs roamed the Earth. So, in terms of astronomical age, they're actually quite young, only a few 100 million years old. This discovery has got scientists all excited because it means something dramatic happened in Saturn's past to create this stunning icy disk. But this is a mystery waiting to be solved. Scientists want to figure out what exactly caused the rings to form and why they have such a breathtaking structure. Let's hope they'll figure it out. But moving on to something more optimistic, we have another exciting space news. Recently, scientists have been studying one of the most distant galaxies in the universe, and they found something amazing: organic molecules. The galaxy in question has a long name, SPT 041847. It's over 12 billion light-years away from our little blue planet. Can you even imagine that distance? It's the farthest galaxy ever known, where complex organic molecules have been found. That's why looking at this galaxy is like looking at something from when the universe was just a baby. We have no idea what this galaxy looks like now. The light that has reached us is what it looked like when the universe was only 1.5 billion years old. Imagine being able to see things from so far in the past. So what they found is something with a very complicated name: a polycyclic aromatic hydrocarbon molecule, or simply PAH molecule. You might be wondering, what in the world is that? Well, guess what? You can actually find these molecules right here on our planet. They can be in things like the smoke from car engines or even forest fires. PAH molecules are made up of chains of carbon atoms. And here's the super cool part. They're considered the basic building blocks for life. Imagine that. Life's building blocks. Those tiny carbon chains. being discovered in a galaxy that's so far away. That's like finding a needle in a haystack. They also found out that gas floating around in that galaxy is filled with heavy elements. That's a big deal because it suggests that many stars have come and gone there, creating all these amazing elements. This means that this galaxy can be potentially rich in many other elements too. This discovery opens up a world of possibilities and raises so many exciting questions. How did these molecules form in a galaxy so distant? And since we're looking into the past, what could have happened to these organic molecules during this time? Could they have evolved into life? We're only scratching the surface of the incredible things waiting to be uncovered. By the way, if it's so far, how did scientists even manage to discover something like that? Well, they had the instrument called the James Webb Space Telescope. This fancy telescope was recently launched and has superpowers when it comes to observing the universe. So when the scientists were studying this faraway galaxy, they had a little problem. The light coming from those distant objects was so faint that it was hard to see or detect. But guess what? They had a brilliant idea to solve this. They used something called gravitational lensing, which is like a special power of nature's magnifying glass. Imagine two galaxies lining up perfectly, just like in a photo shoot. The light from the faraway galaxy, the background one, travels towards us. But on its journey, it passes through the foreground galaxy, which is like a giant space lens. And guess what? The foreground galaxy's gravity bends the light, just like a magnifying glass, making it bigger and brighter. It's like having a cosmic zoom lens for our telescopes. This bending of light creates a super cool shape called an Einstein ring. It's like a halo, or a ring of light surrounding the foreground galaxy, basically a nature's way of showing off its magical powers. With gravitational lensing and these beautiful Einstein rings, scientists can see distant objects more clearly and learn amazing things about the universe. And thanks to all that, they managed to uncover the hidden chemical interactions from the early galaxies. Isn't that incredible? The scientists are beyond excited about this discovery. They never expected to find such complex organic molecules in a galaxy that's incredibly distant. Who knows? Maybe this is just the beginning of a thrilling cosmic journey. So, keep your eyes on the stars, fellow space explorers. The universe is full of surprises, and who knows what other mind-blowing discoveries await us out there. Let's hope we'll learn even more in the future.
Now, it's been a long time since there was a supernova in the Milky Way. Over 400 years to be precise. So hey, we're long overdue. So here are the most likely stars to go boom, if they haven't already. At the top of the list must be the southern hemisphere star Eta Carinae. Greek letters before the name of the constellation indicate the rank of the star's brightness in that constellation. Sir Edmund Halley, in 1677, recorded Eta Carinae as the seventh brightest star in the constellation Carina, Eta being the seventh letter in the Greek alphabet. It might not have looked very bright to Sir Edmund and his contemporaries in the 17th century, but modern studies of Eta Carinae estimate it's 5 million times more luminous than our Sun. Luminous is a technical word astronomers use. It doesn't just mean brightness. Luminosity refers to the total energy released at all frequencies. Eta Carinae releases 5 million times more energy than the Sun. Truly one of the whoppers of the Milky Way, Eta Carinae is 100 times more massive and 240 times larger than our yellow-white dwarf sun, Sol. Obviously, since it appears dim, Eta Carinae is pretty far away, about 7,500 light-years away. Yet even at this distance, if this star goes hypernova, it can still impact Earth's ozone layer, disrupt satellite communications, and harm astronauts. 159 years after Halley's observation, Eta Carinae experienced a nova-like explosion. It increased from a relatively dim star to become the second brightest star visible from Earth, but only for a period of 27 years. From 1836 until 1863, Eta Carinae was the second brightest visible star after Sirius, the dog star, and Sirius is only about 8 light-years away. Since 1863, aside from a couple of flare-ups, Eta Carinae has dimmed back down to its original brightness at magnitude 4.5. Now, astronomers owe us a small apology, which we don't expect to get anytime soon, for star magnitude nomenclature. The brighter a star is, or planet, or moon, the lower its magnitude. Thus, stars brighter than first magnitude are either 0 magnitude or negative magnitude. The full moon, for example, is magnitude negative 13. A magnitude positive 4.5 star, like Eta Carinae, is quite dim as seen from Earth, but it's clearly visible in a night sky without light pollution or clouds if you live anywhere south of the latitude of Cairo, Egypt. 30 degrees north latitude is the farthest north you can see this star. Now, listen up. Eta Carinae is currently up to something. It's been brightening again and is now brighter than at any time since 1864. It's a complex situation. Eta Carinae is really 2 stars, Eta Carinae A and Eta Carinae, what's your guess? Oh, B. There's a third star nearby that's also interacting with the double star's dynamics. Now, without looking, I'm guessing it's named Eta Carinae C. Good guess. Blown out into 2 incredibly massive globes of gas that are expanding at 20 million miles per hour, Eta Carinae is, without a doubt, one of the strangest looking stars you'll ever see. Remember, it's located at a great distance of 7,500 light-years away from us. And if anything had happened to Eta Carinae in the last 7,500 years, like going hypernova, we wouldn't be able to see it, because none of Eta Carinae's electromagnetic radiation would have gotten here yet. Astronomers are keeping a close watch on Eta Carinae because it can go hypernova at any time. Or maybe it already did 5,000 years ago, in which case we'd only have to wait another 2,500 years to see it. Yeah, like I'll put it in my planner. Now, from a list of over 30 likely candidate stars that might go supernova, Rho Cassiopeiae is many astronomers' choice. Another Greek letter, Rho, is the 17th letter in the Greek alphabet. It means that Rho Cassiopeiae is the star with the 17th brightest apparent magnitude in the constellation Cassiopeia. Yet Rho Cass, a nickname, is only one of 7 known yellow hypergiant stars in the Milky Way. It's another whopper. To be seen at magnitude 4.5 from a distance of about 10,000 light-years away, Rho Cass must be a very large star, a hypergiant. Placed where the Sun is, Rho Cass would encompass the orbit of Mars. But it's still yellow. It's not a red giant star. Red indicates a cooler surface temperature. Rho Cass, as huge as it is still as hot on its surface as our Sun, or even a little hotter. That can only mean 2 things. Deep inside its core, Rho Cass is fusing atoms much heavier than hydrogen or helium. Plus, Rho Cass is producing much more energy than a red giant star. In the year 2000, Rho Cass erupted massively. It brightened by 2 orders of magnitude as it ejected 10,000 times the mass of Earth into space at 4 times the speed of sound. Astronomers detected the signature of titanium oxide in this eruption. This means that Rho Cass is much closer to going supernova, or in this particular case, hypernova, than astronomers used to assume. Iron is just a few steps above titanium in the periodic table, and when iron forms, fusion stops and a star collapses. Rho Cass is really close, or more correctly, was really close. Because the eruption we saw in the year 2000 really happened 10,000 years before, many astronomers think Rho Cass has already gone hypernova, formed a black hole, and doesn't even exist anymore. Meanwhile, Betelgeuse caught everyone's attention not so long ago. The star, not the movie. It dimmed dramatically, appearing only 37% as bright as it usually is. Is it getting ready to go supernova? Betelgeuse is by far the brightest star in the whole sky, in infrared light. This is an important fact because it relates to Betelgeuse's status as a supernova candidate, as we shall soon see. Betelgeuse is also named Alpha Orionis, another Greek letter designation. So we should conclude that Betelgeuse is the brightest star in Orion, right? Wrong. It's the second brightest star in its constellation. Rigel, or Beta Orionis, is the brightest one in that region. Figure that one out. It may be because Betelgeuse is classified as a semi-regular variable star, which sounds kind of redundant to me. Its approximately 400-day cycle of pulsation changes its brightness by about one full magnitude, going from much brighter than a first magnitude star to closer to a second magnitude star. But never was Betelgeuse observed to dim so rapidly or so drastically as it did recently. So what's going on with it? Well, from late 2019 to mid-2020, Betelgeuse went through a period of substantial dimming during a mass ejection event. The world astronomy community jumped on the situation, and in the course of their investigations, they came up with some surprising new factual data on Betelgeuse. First, Betelgeuse is not as far away as we once thought. The new, more accurate distance for Betelgeuse is 548 light-years. That's 25% closer than previously measured. The second new fact, Betelgeuse's diameter has been reduced by the same percentage. The star is now known to be 25% smaller than previously believed. The cause of Betelgeuse's dramatic dimming was also determined. The giant star ejected a cloud of gas that contained magnesium. The cloud blocked a large portion of the light coming from Betelgeuse and made it appear visually much dimmer than it really was. Magnesium is not halfway to iron on the periodic table, which means Betelgeuse is not as far along on the path to a supernova as was suspected previously. When iron starts forming in a star, it means that this star is close to shutting down its fusion reactions. The next step is implosion. We aren't quite there yet with Betelgeuse. This star emits most of its energy as infrared light, and it also indicates that its core is most probably still burning helium, and not something that would greatly increase the amount of heat, like carbon for instance. Betelgeuse will still go supernova, but not for another 100,000 years. So you can cross it off your supernova list for the time being. And as for how to correctly pronounce Betelgeuse, you can say it any way you like. There are as many different pronunciations out there as there are people who think they know how to pronounce it correctly. Now, supernova 1987A caught astronomers off guard when it lit up the large Magellanic Cloud 100,000 plus light-years away from the Milky Way. That's when attention was turned to a similar star much closer to Earth, Rigel, in the constellation of Orion. Could Rigel surprise us and suddenly go supernova? There's something called the supernova problem that you should, probably know about because it may relate to Rigel going supernova or not. It seems that stars over 17 solar masses don't always go supernova. Recently, a red giant star simply vanished. Once again, it didn't go supernova, it disappeared. This had often been happening in computer simulations of supernovae, and now it finally occurred in real life. Rigel's mass is 21 solar masses. In other words, it's 21 times more massive than our Sun. So, will Rigel go supernova or simply vanish into a black hole that it'll create in its core? Astronomers and physicists continue their work of learning more about the dynamics of massive stars, scouring the sky for the next supernova in the Milky Way. Meanwhile, we can rest confident that we on Earth are in no danger from the harmful effects of nearby supernova explosions. We live in a nice, quiet, peaceful, stellar neighborhood, except for those Martians next door.
When you look at the night sky, it seems like there's not much happening up there, and that the stars always twinkle at the same spot. For thousands of years, researchers followed the idea that the lights in the sky were unchanging. Sailors guided their ships using fixed stellar patterns. There are also the exact outlines of constellations we observe today, and astronomers identified them a long time ago. It seems impossible that one day we wake up and simply can't see some stars anymore. Or does it? A team of researchers at Vanishing and Appearing Sources During a Century of Observations, or VASCO, studied the sky to check how things with the stars are going. The astronomers got the data from Gaia, the European Space Agency, and compared the information from 70 years ago to that from today to see how the sky has changed. To test it right, they had to use both modern and old telescopes. And something really interesting happened up there. Over 700 stars from the old maps were missing. If one star disappears, multiple theories could work. But it's harder when hundreds of them vanished at the same time. Could it be that the data was wrong? Or these stars were too faint to detect? Nope. They quickly eliminated this option because these stars had clearly been part of their earlier observations. So, the first thing that comes to mind when talking about how stars disappear is that they reached the point where they ended their lives. You can have the most massive stars of all, and we're talking about those that are way heavier than our sun, and they go through sudden changes as they get to the end, which we also call a supernova. It's a powerful explosion that later shines for many, many months, and it's still visible even across hundreds of millions of light years. But that's the point. You see the traces, unlike here. Could this be a failed supernova? That means maybe one of them collapsed but turned into a black hole and consumed the remains from the inside out without causing a powerful explosion. But no one's been mentioning any signs of a black hole being active anywhere near those stars. And what if the stars had become less visible because of dust or gas around them? This is something that can easily happen, as interstellar dust and gas do block our view of objects that are far away. But there were no traces of unusually high concentrations of dust or gas. Nothing destroyed them either. Researchers would have seen traces if something like that had happened. Plus, these missing stars were not all in the same area, which means there probably wasn't just one fatal thing that made them all disappear. Also, the stars were not at the same stage of their life, so it's not an option they were all accidentally close to their end. They weren't particularly old or young, and they were on different levels in size and brightness. At some moments, it even seemed these stars haven't vanished because of some natural events. Maybe it was something related to other civilizations that might be somewhere out there in space. Maybe that's one of the ways to look for them. We could stumble upon some secret civilizations from other planets if we carefully observed the behaviors of stars, especially those we can't explain. No one knows what exactly happened with the missing stars, and unfortunately, right now, all we have are these theories. But you have to admit, they're cool though. Maybe it's just some kind of optical afterglow caused by gamma-ray bursts, or maybe even fast radio bursts. Fast radio bursts are powerful pulses of radio waves. They can release more energy in a couple of thousandths of a second than our giant sun does in almost 100 years. We don't really understand how these energy eruptions work yet, so we don't know what they can do. But still, hundreds of stars at approximately the same time. There are between 100 to 400 billion stars in our galaxy, so we'll probably see some of them disappear too. Hopefully, we'll understand better why such things can happen. Of course, scientists are not sure about this number because we can't see all of the Milky Way stars from our home planet. Some are too faint, some are too far, or even hidden by dust or gas. But they assume these numbers based on the size, shape, and likely mass of the Milky Way. And out of billions of stars, there are a little over 9,000 of them we can see with the naked eye. If you want to see more, you need a good telescope that will reveal those fainter ones your eyes are unable to discern. Many of the stars we see in the night sky are probably not alive anymore. Stars are giant balls of gas that produce light and heat through nuclear fusion in their cores. However, stars also have a limited lifespan, and eventually, they run out of fuel and stop shining. When a star passes, it can either become a white dwarf, neutron star, or black hole, depending on its size. Scientists have discovered that some of the stars we see in the night sky are too old to still be shining. This means that they may have faded, but we are still seeing their light because it takes so long to reach us. Actually, we may be looking at the past when we look up at the stars. Check out all of the stars you can see with your bare eyes. They lie within about 4,000 light years of us. That means what we're seeing are stars that appeared 4,000 years ago. Most of the stars we know of exist within galaxies, which are massive collections of stars, gas, and dust held together by gravity. Still, there are large areas of empty space between galaxies too. And the question is, could they have any stars? It seems that these areas of space are not completely empty. There is still some gas and dust, as well as dark matter, which is a type of matter that we cannot see but we know exists because of its gravitational effects on other objects. Scientists have even discovered a few isolated stars in these areas of space. These stars didn't form there. They ended up there by accident, which means they have probably been ejected from their galaxies by gravitational forces or collisions with other objects. And there could be more of these stars than we realize, but they are simply too dim to be seen from Earth. Stars don't actually twinkle. It's more that we just see it like that from the Earth. It seems like they twinkle because of the turbulent atmosphere of our planet. The light from a star must pass through many layers of the atmosphere. Not every layer is equally dense, so this causes the light to slightly deflect and change in color and intensity. There's one star named Sirius that sometimes twinkles, sparkles, and flashes so much that some people even tend to report it as something extraterrestrial. This is because Sirius is very bright and is often low on the horizon, which means it experiences more of these special effects of the Earth's atmosphere. When in space, astronomers and astronauts who observe stars from there don't see them twinkling. Hey, want to hear something cool? Me, you, your friends, the rest of humanity, we're all made of stardust. The elements that make up human bodies and all life on Earth were formed inside stars. The building blocks of life, such as carbon, nitrogen, and oxygen, were created inside stars and were eventually released into space when the stars were gone. These elements then became part of new stars, planets, and eventually life on Earth. The iron in our blood was created in the cores of supernovas, which are massive explosions that occur when stars fade. Some say that even the calcium in our teeth and bones is likely to come from exploding stars. The oxygen in our lungs was created in the cores of massive stars before being released into space through supernovas. More than 1 million Earths can fit in our sun. New research shows that between 20% to 35% of suns eat their own planets, and a quarter of planetary systems orbiting stars like the sun had a chaotic past. The very thing that gives life can also take it away. All the planets in our solar system revolve around the sun, and they all do it in a somewhat consistent way. It's most likely that they stayed that way ever since they first came into the picture, but not all of them. This chaotic existence means that a solar system had a lot of planets in the litter until the host sun decided to melt them away. Our solar system is panned out perfectly so that no planet's gravity interferes with each other. The gravitational force on Jupiter is a lot tougher than Earth's, which means that if Earth gets close to Jupiter, we'd be another moon for Jupiter. The planet is so big that if Earth were the size of a grape, Jupiter would be the size of a basketball compared to it. Even with the best technology in the world, it's difficult to tell if stars do, in fact, eat their planets. The best way to study this is to observe binary systems. That's just a sciencey way of saying a system with two stars orbiting each other. Usually, the two stars were formed around the same time from the same gases and the same conditions. It means they should contain the same elements, more or less. When you open your eyes in the morning, the sunlight that's been traveling for millions of miles greets you. The closer we get to it, the hotter it is. But the rays traveling from the sun also contain certain chemicals that make it unique. The chemicals that are associated with the sun are light materials like oxygen, carbon, hydrogen, and helium. You can find some other stuff in it too, but these are the main ones. By studying these elements, you can learn the history of a solar system with enough detail to determine if it was chaotic or smooth. Scientists studied 107 binary systems composed of suns like ours by analyzing the light. Since each system contains two suns, they compared and contrasted them to see the differences. They observed the stars with a thin outer layer, having different elements than their companion. All suns contain light elements, but there are some that have rocky elements, like iron, silicon, and titanium near the sun. These elements are associated with rough terrains that you'd find on the surface, but they're out there floating in the middle of space. The thinnest outer layer is especially rich in iron compared to the other layers. Many stars are twins at birth. Even most of the Milky Way stars have a buddy in a binary system. It means our sun is pretty unique for not having a partner. But there are some theories out there that suggest that the sun may have lost its twin in the past. It's around 184 light-years away and is called HD 186302. This might be our lucky star. A stellar nursery is where thousands of stars are born. They're made up of gas and dust that gradually collapse under their own weight. Our sun may have started in such a way 4.6 billion years ago. And when they're mature enough, they go out into the open, usually with their travel buddy. Actually, scientists claim that up to 85% of all stars could be in binary pairs or have more buddies, but over 50% are dual pairs. The only problem is that we can't really see it, since it strayed from its original orbit an eternity ago. But traces of it can be found in the Oort cloud. That's the vast cluster of space consisting of comets, space rocks, and ice in the outer edges of our sun's reach. They float around quite a lot, since they're far off the sun's gravity and can easily be knocked out of their orbit into open space. Flying through such a space is no different than flying through any random void of space. The reason why some of these light elements in space contain rock elements you'd find on the surface of a planet is because the sun knocked them off their orbit and devoured them as they got closer. It also happens when a star becomes too big in its place and starts eating everything around it. According to scientists, if a star eats a planet, it can make it go chaotic and spin so quickly that it eventually rips apart. But don't worry, there's a very low chance of the sun devouring the planet in the near future. Stars are formed when a huge cloud of hydrogen and helium grows until it collapses under its own weight. The pressure increases and reaches extreme heat levels we can't even measure. Eventually, the hydrogen atoms lose their electrons, causing the hydrogen to fuse together and release energy, countering the gravity collapsing. But when the gravitational force overpowers the hydrogen fusion, the star begins to expand and becomes a red giant. And then, after around 1 billion years, the hydrogen in the outer core will go away, leaving plenty of helium hanging around, which will fuse with the rest of the elements around. And once all the helium disappears, gravity will shrink the red giant into a white dwarf. And when it's completely gone, the remains of the star release tons of gas and dust into space. Scientists claim that our sun has between 7 to 8 billion years left before it reaches that stage. But even if that becomes a reality, it wouldn't happen overnight. Something like this takes millions of years to take place. But what if the sun decided to devour us overnight as we speak? The planet would start feeling hot in seconds. Every slight degree change can lead to some catastrophic events. Ice caps can melt in a matter of seconds and flood the coastal lands. Even little islands in remote areas of the world will be submerged. And as it gets hotter, every snow-capped area will melt instantly and turn into desert-like climates. Some places will burn, and your everyday objects will melt on the spot. The Earth's interior will also get hotter, allowing volcanic eruptions to happen across the world. Antarctica will melt from the heat, as well as the volcanoes erupting inside. And just in a matter of minutes, the whole planet will turn into fire and ash before it explodes into tiny bits floating in space, reaching areas we've never even heard of. But no worries, something like this won't really happen. In case the sun knocks us off our rotation, the results would be different. It'll also get hot because the magnetic field around us protects us from the sun's radiation. And once we get knocked out of place, the magnetic field gets tarnished, and the extreme heat from the sun will boil us. The gravitational force will be unstable, so the physics of our everyday life will be chaotic. We'll have to wait 5 billion years from now when the sun turns into a red giant. It'll grow in size, eventually eating up Mercury and Venus. Chances are, Earth will also be on the menu. If Earth were to move only 900,000 miles closer to the sun, then it would be uninhabitable. It may seem like a lot, but it's only 4 times the distance between the moon and Earth. Detecting the chemical composition of the sun rays in solar systems that are further away could help scientists find other Earth-like planets. Since the atmosphere around these planet-eating stars changes the chemical composition, we can detect which solar systems out there have had a calm past. The main thing we have to observe is if the planets have a healthy orbit cycle. With nothing else getting in the way, we can assume that the planet could follow the same steps as Earth did for humans to be here. But this process will take ages, since there are millions of nearby stars similar to our Sun. The odds of finding a planet similar to ours are near impossible at this rate. But if so, then there might be life on those planets. There will be no way of knowing if it's intelligent life, but they might have had the same evolutionary fate as us.
Castles were cold places in times past. The stone seemed to radiate the winter chill. This is one practical reason why tapestries were hung upon castle walls, to help keep the cold out and the warmth in. But you just can't hang any old thing on castle walls. It should be beautiful, heroic, with a heavy wow factor. The ancient Greeks hung tapestries on the walls of their castle of the sky, glorious tapestries woven of stars. All 48 constellations of the Northern Hemisphere were designed and named by the Greeks. The story of Andromeda is one such tapestry, woven of 7 constellations spread across the entire autumn sky. The story contains detailed astronomical observations preserved as highlights in the sky tapestry. It begins with the constellation Cassiopeia, queen of the oldest realm in Africa, Ethiopia. When the constellation Cassiopeia is on the horizon, it looks like a staircase going up to the Milky Way. Step pyramids around the world are often thought to have been inspired by the constellation Cassiopeia. In any case, Cassiopeia is a beautiful constellation, indicating that Queen Cassiopeia was also a beautiful woman. She was good-looking, but equally vain, which sets off all the dramatic action. Cassiopeia can be found in the night sky opposite Ursa Major from the North Star. Like Ursa Major, Cassiopeia circles the North Star and is a circumpolar constellation. A supernova was observed in Cassiopeia around 1680 Earth time, Cassiopeia A having occurred about 11,000 years earlier. The Chandra X-ray satellite recently recorded an extraordinary photograph of this supernova remnant showing the elements sulfur, calcium, silicon, and iron amid the expanding cloud's high-intensity X-rays. Cassiopeia's husband is also a circumpolar constellation, a minor, dim one named Cepheus. He had his own kingdom. A merger of empires by way of marriage is something common throughout history. Cepheus was a king of Phoenicia. There were many kings of Phoenicia back in the days when Phoenicia was just a collection of city-states along the western shore of the Mediterranean Sea. Cepheus can be found in the area between Cassiopeia and the North Star. The constellation of Cepheus is important to astronomers. It's where Henrietta Swan-Leavitt discovered variable stars that pulsed at regular intervals. The rate of pulsation of the star indicates the true brightness of the star and enables a sure measurement of the distance to the star. The discovery of Cepheid variable stars was a major breakthrough for early 20th century astronomy. Cepheus and Cassiopeia had a daughter, Andromeda, also a noted beauty, about whom all the fuss is. It seems that one day Cassiopeia was boasting about the beauty of her and her daughter Andromeda. "We are more beautiful than any other women in the whole wide world." Well, such pretension can be forgiven for a queen. But then Cassiopeia went further and stepped beyond all natural bounds. In fact, "We are more beautiful than any of the Nereids." Well, the Nereids were Greek mythological sea nymphs, daughters of the ocean. Noted for their beauty and kindness to sailors, the Nereids, all 50 of them, took offense at being dissed by a mere mortal woman. Cassiopeia had to be punished for exceeding the bounds of the civil order. By her excessive vanity, Cassiopeia transgressed beyond the bounds of nature, for which an unnatural punishment was inflicted upon the entire kingdom of Ethiopia. A monster from the bottom of the ocean, the constellation Cetus, began to devastate the coastal villages of Ethiopia as well as Ethiopia's fishing ships. Fittingly, Cetus is a constellation of the southern celestial hemisphere. The fourth largest by area of all the constellations, Cetus swims in a dark part of the sky called the ocean, with only its head rising above the celestial equator. This part of the sky contains several water-themed constellations: Pisces, the fishes, Aquarius, the water-bearer, and Eridanus, the river. Over 50 exoplanets have been discovered in Cetus. You can bet the James Webb Space Telescope will have a field day analyzing the spectra of these planets' atmospheres, looking for signs of life. Meanwhile, Queen Cassiopeia and King Cepheus must do something about the monster devastating the shores of Ethiopia. They consult an oracle and make another trespass beyond the realm of reason and nature. Tell us, oracle, what can we do to stop the monster from ravaging our kingdom? This monster is not a normal affliction of nature. An offense was committed against the higher realms, and this is the punishment. The monster cannot be stopped by any normal means. Only a human sacrifice of the noblest being may placate the beast. One error compounds another. The noblest person in the kingdom, of course, is Princess Andromeda. According to the command of her father and the consent, or perhaps a suggestion of her mother, Andromeda is chained to a rock offshore. She is the human sacrifice that her parents hope will save the kingdom. Wow. Da-da-da-da! Here comes the Greek hero to save the day, stop the human sacrifice, and turn Cetus to stone. Perseus. Now, where is Perseus coming from? According to legend, the Hebrides. Perseus went to the Hebrides in pursuit of the Gorgon Medusa. The geological scope of this tapestry is incredible, from the Hebrides to the Red Sea. The Hebrides are an archipelago of mostly rocky islands off the western coast of Scotland. It was impossible to sail any further. The Hebrides were the absolute end of the world. Perseus didn't have to sail to the Hebrides. However, he flew on a pair of winged sandals. Hey, way to go, Perseus! Now, Medusa was one of the all-time baddies. One look at Medusa was so terrifying it would petrify you, literally turn you to stone. Perseus was in great danger. So, what did our hero do? Instead of looking at Medusa, Perseus used the scientific principle of reflection. He slew Medusa by seeing her reflected in his polished shield. In our sky tapestry, Perseus is portrayed holding up the severed head of Medusa. In the night sky, one eye in Medusa's head opens and closes and opens again. Arabic astronomers named the star Algol, the ghoul. Algol is an eclipsing double star. One star is bright, the other one, not that much. As the dimmer star orbits the bright star, it passes in front of the bright star, eclipsing it, and the eye closes. Since the dim star takes 2 days, 20 hours, and 49 minutes to orbit the bright star, the eye in Medusa's head opens every day and a half or so. The constellation of Perseus is immediately below Cassiopeia, and sky watchers quickly look to see if Algol is eclipsed, if Medusa's eye is open or closed. Perseus flew back from the Hebrides, accompanied by Pegasus, the winged horse. The central part of Pegasus is the Great Square, made up of 4 stars. As Earth goes around the Sun, the Great Square is right in the center of the night sky in autumn. In the summer triangle of Vega, Deneb, and Altair are in the middle of the night sky. In spring, it's Leo the lion, and in winter, it's Orion the hunter. These are the walls of the castle in the sky, and all have marvelous tapestries adorning them. The constellation of Andromeda shares a star named Alpheratz with Pegasus. It's one of the corners of the Great Square, so it appears Andromeda may be riding on Pegasus. Her crown, remember she is a princess, is floating nearby. M31, the Andromeda Galaxy. To see M31, cross the corners of the Great Square from the lowest star to the uppermost star, and then go a little further to see the Andromeda Galaxy. Be sure to peek at it from the corner of your eyes. It's called averted vision. The corners of your eyes are more sensitive to light, so you'll be able to see the huge spiral galaxy 2.5 million light-years away as a smudge of light 1.5 times wider than the full moon. Now, Perseus doesn't go in for human sacrifice, so he stops it and saves Andromeda by exposing Cetus to Medusa's gaze. And here we encounter the second eclipsing variable in our sky tapestry, Mira, the heart star of Cetus, the sea monster. Mira, from which we get the English word mirror, so fitting in a story about vain beauty, is an eclipsing double star. The dim star orbiting the bright star is a white dwarf, not bright enough to see with the unaided eye. The effect is that Cetus's heart shuts off. Mira is eclipsed and disappears. This cycle repeats itself every 332 days. Our fabulous star tapestry has the only two eclipsing binary stars visible to unaided eyes, the nearest spiral galaxy, and a hero that doesn't like human sacrifice and uses the scientific principle of reflection to thwart mythological monsters. Wow, I would hang that in my castle too. Just saying. About 800,000 years ago, I wasn't around then, a gigantic asteroid soared through space and plummeted toward Earth. It slammed into our planet with enormous force. It blanketed 10% of Earth with shiny black and green lumps of rocky debris known as tektites. Tektites are pieces of rock that get liquefied by the heat of a meteorite impact. Then they cool down to look like dark, glassy pebbles. A trail of these tektites was strewn across Southeast Asia and reached all the way to eastern Antarctica. This is how scientists know this giant meteorite crash happened. Well, researchers spent nearly 100 years trying to find the gigantic crater caused by the impact. But tektites were too widespread. That's why they couldn't pinpoint the exact location until recently. A team of experts from different universities tried to discover the ground zero of the meteorite impact. They investigated several craters in China and Cambodia, but none seemed to be created by a meteorite crash. The experts then decided to investigate Laos. It's a country where they discovered the largest and most concentrated number of tektites. After ruling out all visible craters, the team came up with a new theory. What if the crater is hidden by something? In search of the potential crater, the scientists measured gravity readings at different locations all across Laos. At the site of an ancient volcanic eruption, below thick, dense layers of cooled volcanic lava, they discovered a severe gravitational anomaly. It turned out to be a large, elongated crater, over 300 feet deep and spreading 8 miles wide and 11 miles long. Based on the location and the crater's enormous size, scientists believe this is the impact site of the ancient meteorite. Meanwhile, over 2 billion years ago, long before the age of dinosaurs, Earth was struck by one of the largest asteroids to ever hit our planet. The asteroid was approximately 6 to 9 miles across and created the biggest impact crater on Earth. This is the Vredefort crater. You can find it in present-day South Africa. When it was formed, it had a gigantic diameter of 186 miles. Over the centuries, the massive crater slowly eroded away into the Vredefort Dome. That's a rocky hill formation that was the central site of the asteroid's impact. This formation is so large that it can be seen from space. Today, the Vredefort Dome is a recognized World Heritage Site. It's also home to several towns and communities that encourage tourists to come and visit the ancient crater. In 1943, one pilot strayed from his regular flight path to avoid dangerous weather conditions. Flying over Quebec, Canada, he spotted a large, perfectly circular basin. That is how the Pingualuit crater was discovered. Around 1.4 million years ago, a meteorite hit this spot, creating this small but deep impact crater. It has a diameter of 2 miles and a depth of 1,300 feet. A lake of deep blue water has formed at the bottom of the crater. It's said that this lake contains some of the purest water in the world as it has no inlets or outlets. It means that the lake is only filled by rains and melting snow. The lake is home to one species of fish, the Arctic char. The Sudbury Basin is also in Canada. Formed over 1.8 billion years ago, it's one of the largest and oldest impact craters in the world. It's located in Ontario, but the impact from the collision was so powerful that debris from it was found 500 miles away in Minnesota. Unlike most impact craters that have a circular shape, the Sudbury Basin is an oval. It's 39 miles long with a width of 19 miles. The original impact site might have been a whopping 10 miles deep, but its modern-day version is much shallower. The asteroid that created the basin carried a high concentration of natural minerals. This made the soil in the crater incredibly fruitful. Today, its floor is home to numerous fruit and vegetable farms. The unique crater formation of Sudbury Basin was used to train Apollo astronauts before they embarked on their missions to the Moon. Perhaps the most famous meteorite of all is the Chicxulub. That's the meteorite responsible for wiping out 75% of all plant and animal life on Earth, including the dinosaurs. The Chicxulub meteorite had a diameter of 6 miles when it struck Earth 66 million years ago. The crater now lies off the coast of Mexico, hidden deep beneath the seabed. It's around 93 miles across and 12 miles in depth. Recently, scientists managed to drill deep down into the highest peak of the impact crater to collect rock samples. They discovered that the disappearance of dinosaurs wasn't caused by the giant size of the meteorite or the scale of the blast. It was because of the exact location where the Chicxulub hit Earth. The meteorite struck part of our planet that was densely filled with a mineral compound called gypsum. It's a soft sulfate mineral that is typically used as a fertilizer. The collision blasted so much sulfur into the air that it blocked out the sun. This caused the prolonged dark winter that doomed the dinosaurs. One of the youngest craters on Earth is the Barringer crater in Winslow, Arizona. The Barringer crater is also one of the best preserved craters on Earth. It was formed 50,000 years ago when a heavy meteorite made mostly of iron plummeted down from space. Earth's atmosphere barely slowed down the massive chunk of metal. It collided with the ground with incredible force. The meteorite vaporized upon impact, leaving very few remains. The crater left by this powerful explosion was named after the man who identified it in 1903. It was a mining engineer named Daniel Barringer. The diameter of the crater is 3,900 feet and it goes 560 feet deep. The Barringer family still owns the impact site to this day. You can visit the crater and take a guided tour around its rim. The Papagai crater in Siberia is one of the most interesting craters on Earth. An asteroid impact over 35 million years ago formed this massive basin. The crater is 62 miles across, which makes it the fourth largest one in the world. This crater is unique as it's home to one of the largest diamond deposits in the world. The intense pressure from the collision transformed the graphite at the impact site into diamonds. Scientists say that the crater contains trillions of carats of diamonds, but no one has ever mined them due to the site's remote location and lack of infrastructure. In the year 1530 BCE, a meteoroid entered Earth's atmosphere before shattering into pieces. The meteorite's burning fragments rained down on Earth and crashed into the planet's surface. As a result, a group of craters appeared on a small Estonian island, Saaremaa. The largest crater is a 360-foot wide perfect circle. It's 70 feet deep and filled with blue water. 8 smaller craters that appeared during the collision can be found within a half-mile radius of the largest crater. The impact of the meteorite fragments caused the trees on the islands to catch fire. Almost all forests burned down. Luckily, the woodlands have now grown back and the craters are a popular hiking destination for tourists. A meteorite struck the area we now know as Quebec, Canada, around 200 million years ago. This collision created the 6th largest impact crater in the world. It had a diameter of 40 miles. Over the century, the outer rim of the crater has filled up with water. It's now known as Manicouagan Reservoir. The impact crater lake is so large it can be seen from space, and its strange shape gave the lake its nickname, the Eye of Quebec. The oldest meteorite crater in the world is in Western Australia. The Yarrabuba crater is 2.2 billion years old. Well, that gets my vote for the best crater name. The impact site is so ancient that the original crater has completely eroded away. Yarrabuba's diameter was around 19 to 43 miles. Scientists managed to figure out the age of the impact site by analyzing the ancient crystals and minerals found within the crater.
Let me take you to a place that seems to be out of this world. Life inside this cave has been isolated from the outside world for about 5.5 million years. And it does show. See for yourself. Due to such a long isolation, the conditions inside the Moval Cave are like nowhere else on our planet. A unique ecosystem is flourishing there, even though there is a severe lack of sunlight inside the cave, and the air is toxic. The cave, located a few miles west of the Black Sea in Romania, was first discovered in 1986. Nowadays, you can only visit it if you have special permission. Plus, the central caverns are guarded naturally by narrow limestone tunnels and vertical shafts. So, if you're no stranger to claustrophobia, you'd probably better not enter this place. In the depth of the cave, the air has twice less oxygen than the air outside. Instead, it contains a lot of carbon dioxide and hydrogen sulfide, so not the freshest air you can breathe. It's also pitch black inside the cavern. But despite, or should I say thanks to, this cocktail of extremely harsh conditions, the site is a true goldmine for biologists. Shockingly, life seems to be booming here. In a 1996 study, scientists identified 48 species, and 33 of them were unique to the cave. Most of the creatures inhabiting the cave are tiny, with long limbs and antennae that help them navigate in the dark. They have no vision and lack pigment, and it makes sense. Why would you need to be able to see if you live in total darkness? And why would you need to be pretty and colorful with no one to see you? Now, I'm going to take you to another cave. It's no less amazing, but looks very different. This is the Giant Crystal Cave, aka the Cave of the Crystals, in Mexico. These ginormous crystals were found in 2000 by a mining company after the water was pumped out of the cave. 2 miners then saw the crystals after entering the drying cave on foot. These awe-inspiring crystals are actually massive gypsum pillars hidden 984 feet underground. They're anchored to the walls and the floor of the scorching hot cave. Scientists estimate that the crystals could have been already growing for 500,000 years. That's why many of them are so long and wide that you can walk across them. Unfortunately, visiting this wonder of nature is impossible at the moment. But maybe it's for the better, since the Giant Crystal Cave is a dangerous place that can easily turn into a trap. For tens of thousands of years, it was filled with groundwater, which was originally pushed upward into the opening by a magma chamber located in the depths of our planet. The magma under the cave kept the water hot, but eventually the temperature of the water dipped below 136 degrees Fahrenheit. As a result, the water started to fill with calcium and sulfate, whose particles began to recombine into gypsum. And then, white-tinted crystals took over the cave. And since they stayed underwater, they were able to keep growing. You don't have to fly to space to take a closer look at a black hole. Scientists have found something very similar to black holes in the southern Atlantic Ocean. A black hole has such an enormous gravitational pull that once something gets pulled inside, it doesn't have any chance to escape. Even light can't get out of a black hole. But ocean black holes seem to be almost as powerful as their space relatives. But instead of catching the light, they do the same with water. Ocean eddies are massive whirlpools that spin against the main current. They usually swirl billions of tons of water, and most of them are larger than a city. These whirlpools are so powerful that nothing trapped by them can escape. But the scariest thing is that you might not even notice heading into one of them. These things are so huge that you won't spot their boundaries until it's too late. When scientists started exploring ocean vortices with the help of satellites, they discovered the borders of several eddies. After that, they managed to prove that, mathematically, these whirlpools are the same as mysterious black holes in space. Massive eddies are surrounded by super-tight barriers where fluid moves in closed loops. Even water can't get out from the inside of these loops. That's why tight ocean vortices play the role of enormous containers. Water inside them can be totally different from the ocean surrounding an eddy. And I'm not only talking about its temperature. The salt content inside and outside a whirlpool often differs as well. On the thin Curonian spit splitting the Baltic Sea from the Curonian Lagoon, there is one of the most bizarre places on Earth. Locals call this area the Dancing Forest because pine trees in this forest have shockingly unusual shapes. They twist in spirals and circles along the ground. There are some theories why it could be happening, of course. Some people claim that huge amounts of positive and negative energies once clashed in that spot. More down-to-earth individuals believe that the reason is geological. Sandy soil in the area is too unstable to hold trees growing upright. The most popular is the idea that strong winds blowing from the water influence the shape of the trees. In any case, experts haven't come to the final conclusion yet. Look at these underwater crop circles. For the first time, they were spotted in 1995, close to southern Japan's coast. Local divers called these 7 feet wide structures mystery circles. The enigma had been plaguing many minds for almost 16 years until the culprit was finally caught. Imagine the researchers' surprise when it turned out to be a male pufferfish. The fish needs a bit more than a week to build one circle, and the aesthetics are obviously crucial. A male is swimming inside the circle, digging valleys in the sand with its fins. But that's not all. The fish also use shells and corals to decorate particular parts of their circles. This whole build-a-circle thing has a practical purpose as well. The way a male fish swims pushes the sand toward the center of the circle and creates a mound which later serves as a nest. The next mystery on our list is in the Caribbean. Just off the coast of Belize, there's a giant sinkhole. That's the Great Blue Hole. It's about 1,000 feet across and more than 400 feet deep. Once, a long time ago, this hole was a cave. But then rising waters filled it, making it collapse in on itself. The deeper you'll descend into the Great Hole's crystalline waters, the darker it will become. You'll see tons of stalactite-filled caves there, but entering them is extremely dangerous, unless you want to get hopelessly lost. Once you reach a depth of 50 feet, you'll notice that the water is shimmering. That's the invisible line dividing the sinkhole's salty top from the freshwater abyss. You might want to turn back right now. Who knows what you might come across in the murky depths. There was an old Amazonian legend that told about the river that was so hot that it boiled. And it was believed to be just a legend until Peruvian geoscientist Andrés Russo questioned if the river could be real. All experts denied such a possibility. After all, hot rivers do exist, but only in the areas where there are volcanoes. As for the part of the country mentioned in the legend, there are no volcanoes in that region. But Andrés Russo was too dedicated to give up. And in 2011, he finally located the river from the legends. The water in it was indeed steaming hot. Its temperature was 186 degrees Fahrenheit, not boiling, but pretty close to this point. But what shocked the researcher the most was the size of the river. One could think that the almost boiling water was the result of the activity of an underwater hot spring. But thermal pools are always small, while the river is 20 feet deep and flows for almost 4 miles. This is the only river of its kind on our planet.
The Earth has 3 main layers. 2 parts of the core, the dense, hot inner core, and the molten outer core. Then comes the mantle. And then follows the thin crust, the surface that supports life as we know it. At least, that's what we thought, because now scientists found a new mysterious layer located deep within the solid inner core. Earth's inner core is approximately 2/3 the size of the Moon, and made of nickel and solid iron. It's burning hot. The temperature at the center of our planet is the same as at the surface of the Sun. The outer core can reach almost 10,000 degrees Fahrenheit. It's difficult to explore it because we can't go there, and it's like looking through a really dirty window of 3,200 miles of molten metal and rocks. But we can rely on laboratory experiments on heated pressurized rocks, signals from seismic waves, and computer models. When an earthquake hits, it sends out seismic shock waves. Those waves travel through layers at a different speed, depending on the direction they go and the material they move through. In the new study, a team of scientists set a data set of 100,000 deep earthquakes. Some of them went over 60 miles below the surface. When an earthquake happens on one side of our planet, scientists track its waves all along to the other side. Waves change when they come to the other side, so scientists try to understand the materials these waves have passed through. They found a new layer in the core of our planet thanks to earthquakes. Normally, shock waves travel along the equator, but down below, they digress and go into different directions, about 60 degrees to the side. When waves pass through the inner core going from north to south, they will travel more quickly than waves going through the core parallel to the equator. It's important to understand the core because it creates our magnetic field, which in turn protects the planet from things like solar winds that are charged particles coming from the sun. In the 1960s, we discovered the Earth pulsates every 26 seconds. It's like clockwork, a giant heartbeat. The ground is slightly shaking, but we mostly don't feel it. Researchers can still track it. Some of them think the continental shelf comes as a huge wave break under the oceans. For example, the highest part of the North American continent falls off into a deep abyssal plain. One theory says waves hit this spot, producing regular pulses. It's like having all kinds of drums. You hit them with your hands and accidentally slam that one spot that produces the right harmonic bang to rattle our entire planet. If this theory is true, We're lucky there are no more spots like this that can shake the Earth. Other scientists believe the pulsation happens because there's a volcano near the critical spot, the island of Sao Tome in the Bight of Boni. You're walking, running, and jumping, but when you stop, it always feels like you're standing still. In reality, you're moving even when you're perfectly still because our planet is always on the move. Depending on where you're at, you could be spinning through the universe at more than 1,000 miles per hour. If you're on the equator, you'll move the fastest. Let's say you have a basketball spinning on your finger. Check the ball's equator. A random point on it has farther to go in just one spin than any point near your finger. That means the point on the equator is moving more quickly. The Earth is a planet that recycles all the time. The ground we're walking on is recycled. Our planet's rock cycle turns rocks of one type into another. That's a cycle that goes on and on. The depths of our planet are filled with magma. As magma is going out onto the surface, it hardens into rock. Tectonic processes like volcanic activity, earthquakes, mountain building, and all of the other processes that shape the surface of our planet bring that rock to the Earth's surface. When the rock is on the surface, erosion shapes it and shaves its bits off. Those small particles then get deposited. All the pressure coming from above compacts the particles into sedimentary rocks, like, for example, sandstone. Sedimentary rocks can also end up deeper and deeper under the Earth's surface. Since there's a lot of heat and pressure, they get cooked into metamorphic rocks. They can go back to the surface once again, or even end up being re-eroded. Sometimes the crust plates are pushing one under another, and this way, rocks can transform into magma once again. We've explored only 5% of the ocean so far. The ocean itself, as well as life below the seafloor, is still a mystery. The sediments that are underlying our oceans are home to different microorganisms that exist even at depths of 1.5 miles beneath the seafloor. There are microbes hidden deep inside volcanic rocks below the seafloor off of the parts of the Pacific, hidden under 870 feet of sediment. The biosphere under the seafloor is growing extremely slowly compared to life on the surface. Cell division happens every 10 to 1,000 years. Something's different about the Earth's axis. Climate changes and melting glaciers, mostly in the regions like the Himalayas and Alaska, made the axis shift. Our planet has two kinds of poles. Are the south and north magnetic poles. They affect things such as drift and navigation. The axis that the Earth is spinning around is another kind of pole. It shifted a little bit over time, but we don't know exactly why. Researchers realize there are moving masses of water, pushing the Earth's axis eastward. Take a basin of water as an example. If you're moving it back and forth, sloshing makes the water move its weight all around. A similar thing is happening on a planetary level. No matter how large an earthquake is, no human could ever feel an earthquake on the opposite side of the Earth, although some people claim they did. In 2013, there was one near the Kuril Islands with a magnitude of 8.5. It went around 400 miles deep. It was so strong, people in Australia reported they could feel the ground shaking. The strongest earthquake happened in Chile in 1960 with a magnitude of 9.5. The rupture zone stretched from 311 miles to almost 620 miles along the country's coast. Earthquakes with a magnitude of 10 or higher can't happen. The magnitude depends on the length of the fault where it occurs. The longer the fault, the bigger the earthquake. A fault is a break in a part of the planet's crust. It has rocks on both sides, and they move past each other. We haven't found a fault long enough to generate earthquakes with a magnitude of 10 or more. If it happened, it would extend around most of our planet. An earthquake with a magnitude of 12 would require a fault larger than our planet. One side of our planet is getting colder than the other. The Earth has a system that keeps it warm from the inside, a red-hot liquid interior deep below the surface. It spins and, at the same time, generates a magnetic field and gravity. That way, the Earth's core holds the atmosphere closer to the planet's surface. The Earth also absorbs heat from the Sun, mostly on the surface. The heat doesn't spread equally on all parts of the Earth. One side of the planet, the Pacific Hemisphere, is losing heat more quickly than another, the African Hemisphere. This happens because land traps more heat than the surface under the ocean. The seafloor is way thinner than the landmass. Also, the temperature caused by the heat coming from inside the Earth is getting lower because of huge amounts of cold water above it. Clouds are not just like some fluffy distant pieces of cotton. They weigh more than 1 million pounds and help regulate our planet's temperature. If you take all the water droplets in clouds and bring them to the surface, you could cover the planet with a liquid layer as thin as a human hair. It doesn't seem like a lot, but this water is crucially important for climate. We'd have warmer temperatures if it weren't for the clouds.